Plant your feet firmly on the ground, feel the solidity of the earth beneath you. Before we travel to the edges of the universe or dive into the mysteries of black holes, we must first understand where we stand. We are here on this small rocky world, drifting through a quiet corner of the galaxy. Take a deep breath. Feel the air filling your lungs. That air is the only thing separating you from the infinite vacuum of space. Now imagine the sun has just set. The bright blue curtain of the day is being pulled back. Slowly the colours shift. The golden orange of twilight fade into a deep bruising purple, and finally into the blackest velvet. This is the moment when the universe reveals itself to you. During the day, our local star, the sun, is so loud, so bright, and so demanding that it drowns out everything else. But night is different. Night is the time for listening. Night is the time for seeing what has always been there, hiding behind the glare of the day. Tilt your head back, look up. At first, your eyes might not see much. We are creatures of the daylight evolved to hunt and gather under the sun. Our eyes need time to change gears. In this modern world, we are rarely in true darkness. Streetlights, car headlights, and the glow of phone screens keep our pupils small and tight. But if you let the darkness settle around you, a biological miracle begins to happen. Your pupils widen, opening like camera lenses trying to capture every possible scrap of light. Chemical changes occur in the back of your eyes. You're switching from your day vision to your night vision. You're preparing to receive messages from the deep past. Consider the star you see directly above you. It might look like a tiny cold pinprick of white light, but what you're actually seeing is a physical connection between you and an object of immense power. Let us trace that connection. That tiny point of light is actually a raging nuclear furnace, a ball of gas burning at millions of degrees. The light you see did not leave that star tonight. It began its journey years ago. Perhaps it left that star when you were a child, or when your parents were born, or perhaps even before human beings walked on this earth. Think about the journey of a single particle of light. Scientists call this a photon. Imagine this tiny packet of energy being born in the crushing heart of a distant star. For thousands of years it struggled just to escape the center of that star, bouncing around, trying to find the surface. Finally it broke free. It shot out into the empty void of space, traveling at the fastest speed possible in the universe, 300,000 kilometers every single second. For years, or maybe centuries, that particle of light traveled through nothingness. It dodged clouds of cosmic dust, it passed by freezing cold planets and tumbled through the silence of interstellar space. It traveled a lonely path across a distance so vast our brains cannot truly comprehend it. It never stopped. It never slowed down. It kept moving, carrying the image of its home, carrying the story of that star. And then it arrived here. It entered our solar system, passing the giant planets like Jupiter and Saturn. It crossed the final stretch of space to reach Earth. It survived the chaotic crash through our atmosphere. And finally, out of all the places it could have landed, on the roof of a house, on a leaf in a forest, or into the dark ocean, it entered your eye. It hit your retina, and in that exact moment the journey ended. The energy that left a star long ago has now become a small electrical signal in your brain. You're not just looking at the sky, you're touching the universe. When you look at the stars, you are literally catching ancient energy with your body. You're connected to those distant figures. However, there is a barrier between us and the vastness. As you stand there looking up, you might notice the stars are twinkling. They shimmer and dance. While this looks beautiful and romantic, it is actually an illusion caused by the air we breathe. We live at the bottom of an ocean of air. We call it the atmosphere. It is a blanket that hugs our planet, keeping us warm and shielding us from the harsh radiation of space. Without it, we could not survive for even a minute. But for an observer of the universe, this atmosphere is like looking through a window that is covered in rain, or looking up from the bottom of a swimming pool. The air above you is not still. It is moving. There are rivers of wind, pockets of hot air rising and layers of cold air sinking. It is turbulent and chaotic. As that ancient beam of starlight comes down through the atmosphere, it gets pushed around. It bends slightly this way, then that way, thousands of times per second. To your eye, the star seems to jump around and change brightness. We call this twinkling. To an astronomer, the atmosphere is both a best friend and a frustration. It allows us to live, but it blurs our view of reality. It reminds us that we are observing from inside a bubble. We are safe inside, looking out at the wild dark. This is why we must find stillness. To truly see the night sky, you cannot be in a rush. The universe operates on a timescale that is much slower than our human lives. Stars live for billions of years. galaxies collide over eons. The light takes millenniums to reach us. To appreciate this, we must slow down our own internal clock. Stand very still. Feel the temperature of the air on your skin. Usually the night air is cooler, crisper. Let the sounds of the day, the traffic, the notifications, the conversations fade away. Imagine you are turning down the volume of the world around you. In this silence, the sky seems to grow larger. The dome of the heavens feels heavier, more impressive. You might start to feel very small. Do not be afraid of this feeling. This feeling of smallness is not about being unimportant. It is about being part of something incredibly large. It is in this quiet state that we can begin to ask the big questions. What is out there? Where did we come from? Are we alone? Tonight we are not just people standing in the dark, we are observers. We are the universe's way of looking at itself. We are eyes that have opened after a long sleep. Before we launch our minds off the surface of the Earth, before we explore the planets and the nebulae, we must appreciate this starting line. We must appreciate the darkness. Without the dark, we would never see the light. The night is not an empty space, it is a canvas, and the darkness is not something to fear. It is the background that allows the stars to tell their story. So stand firm. Let your eyes adjust. Let your breathing slow down. Let the barrier of the atmosphere remind you of how fragile our home is, and let the ancient light land on your eyes. We are ready to begin. The journey starts not with a rocket, but with a look. The night is waiting. As we sever the invisible tether of gravity and drift away from the Earth, the first thing you notice is not the darkness, but the silence. On our home planet, silence is rare. Even in the quietest forest, there is the rustle of leaves or the movement of air. But here in the vacuum, the silence is absolute. It is a heavy velvet curtain that hangs between the worlds. We are entering the silent neighborhood, our cosmic backyard, which is far vaster and far lonelier than any map can truly show. As the blue marble of Earth shrinks to the size of a coin and then a grain of sand, we turn our faces toward the deep dark. We are not just traveling through distance, we are traveling through the archives of history. Every mile we cross is a journey into the past, visiting the family members of the sun that have traveled with us for 4.5 billion years, the King of Storms. Drifting past the rusted, dusty memory of Mars and navigating the rocky minefield of the asteroid belt, we arrive at the true monarch of this neighborhood, Jupiter. To call Jupiter a planet feels like an understatement. It is a solar system within a solar system. If the sun is the father of this family, Jupiter is the boisterous, overpowering uncle. He is massive, terrifying, and incredibly beautiful. As we approach, the silence of space seems to vibrate with his power. Jupiter does not have a solid surface to stand on. He is a creature of gas and liquid metal, a ball of swirling clouds that are thicker than Earth is wide. His personality is one of chaotic violence. Look at the great red spot. It looks like a wandering eye staring back at us. In reality, it is a hurricane that has been raging for hundreds of years. It is a storm so large that you could drop the entire Earth inside it and still have room to spare. This planet screams across the radio spectrum. His magnetic field is a trap of deadly radiation humming with energy. He is the protector of the inner solar system, using his massive gravity to catch stray asteroids and comets, swallowing them whole before they can hurt Earth. He is a violent guardian, beautiful but deadly, painted in stripes of cream orange and brown ammonia clouds. The Lord of the Rings, leaving the king behind, we sail further into the dark to meet the jewel of the neighborhood, Saturn. If Jupiter is the shout, Saturn is the whisper. This planet is the artist of the family. Saturn is famous not for its body but for its jewelry. The rings are the most glorious sight in the local universe. From a distance, they look like solid discs of gold and silver, perfectly smooth. But as we get closer, we see the chaotic truth. The rings are made of billions of pieces of ice and rock, ranging from the size of a grain of sugar to the size of a house. They are the wreckage of moons that died long ago, crushed by Saturn's gravity. Yet Saturn organizes this debris into a masterpiece of order and symmetry. Saturn's personality is light and airy. In fact, the planet is less dense than water. If you had a bathtub the size of the galaxy, Saturn would float. But do not let the beauty fool you. Underneath those golden clouds, winds blow at speeds of 1,800 kilometers per hour. It is a beauty that masks a fierce interior, a silent giant draped in a halo of ice. The lonely ice giants. Now the journey changes. The sun, once a blinding ball of fire, is now just a very bright star in the distance. The warmth is gone. We are entering the realm of the ice giants, where the neighborhood gets quiet, cold, and lonely. First we pass Uranus. He is the oddball of the family, the eccentric one. While all other planets spin like spinning tops, Uranus rolls on his side like a ball. Perhaps long ago he was knocked over by a massive collision, and he has never recovered. He glows with a pale, ghost-like blue-green colour caused by methane gas. He is freezing featureless to the naked eye, and deeply mysterious. He keeps his secrets to himself, turning slowly in the dark freezer of space. Then we reach the edge of the main map, Neptune. Neptune is the sentinel. He stands at the gate, the furthest major planet from the Sun. His personality is one of intense cold loneliness. The light here is dim like twilight on a cloudy winter day. Neptune is a deep, rich azure blue darker than the oceans of Earth. But Neptune is not asleep. Despite being so far from the Sun's heat, he is incredibly active. He possesses the fastest winds in the solar system. Supersonic gales whip around the planet, screaming through the frozen atmosphere. Neptune is the definition of isolation. He orbits in the dark, taking 165 Earth years to complete just one trip around the Sun. To visit Neptune is to understand what it means to be truly alone in the dark, the frozen attic. We have passed the planets, but we have not left the neighbourhood. We are now entering the Kuiper Belt. Imagine a messy attic where you store old boxes, forgotten toys, and things you do not need but cannot throw away. That is the Kuiper Belt. It is a vast ring of debris surrounding the solar system filled with trillions of icy objects. This is a graveyard of creation. The objects here are the leftovers from the birth of the planets. They are time capsules frozen in a deep sleep at temperatures near absolute zero. It is quiet here. The distance between objects is vast. Among these frozen wanderers are the comets. They are the sleeping dragons of our story. Take, for example, the comet you mentioned at 3i Atlas. Out here it is just a dirty snowball, a jagged rock covered in dark ice tumbling silently in the void. It has no tail, it has no glow, it is effectively dead. But these objects have a hidden destiny. Occasionally, gravity from a passing star or a nudge from Neptune disturbs their sleep. They begin to fall inward toward the Sun. As they get closer to the warmth, they have never known they wake up. The ice turns to gas and they grow magnificent tails of dust and light, becoming the celestial fireworks we see from Earth. But for now, here in the Kuiper Belt they wait, the boundary of home. As we look back from this frozen outer rim, the Earth is invisible. Even Jupiter is just a speck of light. We are standing on the porch of our house, looking out into the true wilderness of the galaxy. This neighbourhood with its angry gas giants, its elegant rings, and its silent, icy watchers is our local bubble of order in a chaotic universe. It is vast, dangerous, and beautiful. It is a place of storms that never end and silence that never breaks. And yet compared to what lies beyond, this is the safe zone. This is the campfire in the middle of a dark forest. We have explored the house, now we must turn around and face the true void that lies between the stars. As we push past the outer edges of our solar system, we cross a silent but monumental boundary. For billions of kilometers we have been protected inside a giant magnetic bubble created by our sun, known as the heliosphere. This bubble acts like a shield pushing back against the galaxy. But now the solar wind, the stream of charged particles that flows from the sun, suddenly drops. The familiar pressure fades away. We have crossed the threshold. We are now in the interstellar void. This is the space between the stars. The first thing you notice is the darkness. Back on Earth, or even near Mars, the sun is a dominating circle of fire. But out here, far beyond the orbit of Pluto, the sun has shrunk. It is no longer a burning disk that warms your face. It has become just another star. It is the brightest star in the sky, certainly, but it offers no heat. The temperature here plunges to near absolute zero. It is a cold so deep that it freezes the very concept of movement. In this profound darkness, we encounter the only human-made objects to ever venture this far. They are the Voyager probes. Launched in the 1970s, Voyager 1 and Voyager 2 have been travelling for nearly 50 years. They are moving at incredible speeds, roughly 17 kilometers per second. Yet in the scale of the universe, they are barely crawling. Imagine the loneliness of these machines. Their cameras were turned off long ago to save power. Their nuclear batteries are slowly dying, losing a little more heat and energy every single year. Eventually, they will go completely silent. They will become cold metal ghosts drifting through the dark. But they carry a message. Attached to the side of each probe is a golden record, phonograph disc made of copper and gold. It contains sounds of earth, the wind, the rain, a mother kissing a child, music from Bach and Chuck Berry, and greetings in 55 languages. These probes are messages in a bottle thrown into the widest, deepest ocean imaginable. The astronomers who built them knew the truth. The Voyagers will likely never hit anything. The void is so empty that they could drift for billions of years without ever colliding with a star or a planet. They will outlast the pyramids of Egypt. They might even outlast humanity itself, drifting silently long after our cities have turned to dust. However, when scientists speak of this void, they do not mean it is perfectly empty. The nothingness is deceptive. This region is filled with what is called the interstellar medium. It is a soup of extremely thin gas and dust. It is not empty, but it is thinner than the best vacuum we can create in a laboratory on Earth. To understand how thin it is, imagine a sugar cube. The air you breathe on Earth contains billions upon billions of atoms in a space that size. Here in the interstellar void, a space the size of a sugar cube might contain only a single atom. Yet because space is so big, these few atoms add up. There are giant clouds of hydrogen and helium left over from the Big Bang. There is cosmic dust, tiny grains of carbon and silicon produced by dying stars, and there are cosmic rays. These are high-energy particles that travel at nearly the speed of light. They fly through the universe like invisible bullets. Without the protection of the sun's magnetic bubble, radiation levels here are much higher. It is a hostile, silent environment where the rules of biology do not apply. But the most overwhelming aspect of this place is not the cold or the radiation. It is the distance. The human brain struggles to comprehend the space between stars. We use a unit of measurement called the light year, because kilometers are too small to be useful. A light year is the distance light travels in 1 year. Light moves at 300,000 kilometers per second. In 1 year, that is about 9 trillion kilometers. To reach our nearest neighbor star, Proxima Centauri, we have to cross more than 4 light years of this empty ocean. Let us try to visualize this. If our sun was the size of a ping pong ball in New York City, the nearest star would be another ping pong ball in Chicago over 1,000 kilometers away. Between those two small balls, there is absolutely nothing but dust and shadow. If you were standing on the deck of a spaceship in this void looking out the window, nothing would change. You could travel for a human lifetime, and the stars outside would look exactly the same. They would not streak past like in science fiction movies. They are so far away that they appear frozen. You would feel as though you were not moving at all, suspended in a permanent state of stillness. Communication becomes a ghost story. If you tried to send a radio signal back to Earth from this distance, you would have to wait hours or eventually years for the message to arrive. If you said hello, you would wait 8 years to hear a response from the nearest star system. The conversation of humanity, our internet, our television, our radio, fades into a whisper here. Eventually it becomes undetectable, swallowed by the background static of the universe. This is the true nature of the galaxy. We often think of space as being full of stars, planets, and nebulas, but mostly the galaxy is empty space. The stars are lonely islands separated by oceans of night that are almost impossible to cross. As we drift further into this deep quiet, the sense of isolation is total. There is no up, no down, no east or west. There is only the center of the galaxy, a bright band of light far in the distance, and the endless indifferent dark. We realize that our home Earth is not just a planet. It is a rare, fragile oasis. Outside of our small bubble of warmth, the universe is a vast, silent cathedral, beautiful in its scale but terrifying in its emptiness. Here in the interstellar void, we learn that we are truly deeply alone. Imagine traveling far beyond our solar system into the deep dark canvas of the galaxy. Suddenly, the emptiness is broken by a structure so vast and beautiful that it defies imagination. You've arrived at a nebula. These are the stellar nurseries. They are gigantic glowing clouds of gas and dust that stretch across hundreds of light years. To our eyes, they might look like peaceful, colourful fog painted in shades of red, pink and violet, but do not be fooled by their quiet beauty. Inside these clouds, the most violent and significant events in the universe are taking place. This is where stars are born. The story of a star begins with gravity. For millions of years, these clouds of hydrogen gas and microscopic dust float aimlessly. But eventually something disturbs the peace. It might be a shock wave from a distant explosion or a collision with another cloud. This disturbance causes pockets of gas to clump together. Once a clump forms, gravity takes over. It acts like an invisible hand, pulling more and more gas toward the center. As the cloud collapses inward, it begins to spin. The atoms inside start to crash into each other, creating friction. The temperature rises. It gets hot, unimaginably hot. At this stage, it is known as a protostar, a baby star hidden inside a dusty cocoon waiting to wake up. For thousands of years, the pressure builds. Gravity crushes the atoms closer and closer together until they can no longer resist. Then the critical moment arrives. The temperature in the core reaches millions of degrees. The hydrogen atoms are smashed together with such force that they fuse into helium. This is nuclear fusion. In a single blinding instant, the star ignites. A massive wind of pure energy blasts the remaining dust away, and a new light turns on in the dark universe. A star is born. The symphony of light and heat. Once a star is born, it enters a long, stable period of life. This is the phase our own sun is currently experiencing. But a star is not a solid ball of fire like a piece of burning coal. It is a delicate, violent balance of forces, a constant tug of war. On one side you have gravity. Gravity is always trying to crush the star, wanting to collapse it into a tiny point. On the other side you have the energy from fusion. The continuous explosions in the core push outward, trying to blow the star apart. For billions of years, these two forces are perfectly equal. Gravity pulls in, fusion pushes out. This balance creates the steady glowing sphere that provides light to planets nearby. Inside the core, a grand symphony of physics is playing. The primary instrument is hydrogen. In the intense heat, hydrogen atoms fuse to create helium. As the famous physicist Albert Einstein explained, this process releases a tiny amount of mass which is converted into pure energy. This energy travels from the deep core, bouncing around inside the star for thousands of years, slowly changing from dangerous radiation into visible light until it finally bursts from the surface. Every ray of sunshine that warms your face is the result of a nuclear collision that happened deep inside the sun thousands of years ago. The death of giants. However, no symphony lasts forever. Every star eventually runs out of fuel. For an average star like our sun, the end is relatively quiet. Billions of years from now, it will expand into a red giant, swallowing the inner planets before gently shedding its outer layers to become a fading ghost called a white dwarf. But for massive stars, those that are 10 or 20 times heavier than the sun, the death is far more dramatic, and it is this drama that makes our existence possible. When a massive star runs out of hydrogen, it does not simply fade away. Its gravity is so strong that it crushes the core even tighter, raising the temperature to billions of degrees. The star becomes desperate. It begins to fuse heavier and heavier elements to stay alive. It fuses helium into carbon, then carbon into neon, then oxygen, then silicon. The star becomes like a cosmic onion with layers of different elements burning furiously, but eventually the star makes a fatal mistake. It creates iron in its core. Iron is the star killer. Fusing iron does not create energy, it consumes it. The outward pressure that held the star up stops instantly. The tug of war ends, gravity wins. In a fraction of a second, the iron core, an object the size of a city but with the mass of a sun, collapses inward at 25% the speed of light. It crunches down until it can go no further, and then with nowhere else to go, it bounces back. The supernova. This is the biggest explosion in the universe since the Big Bang. For a few weeks, this single dying star shines brighter than an entire galaxy of billions of stars. The explosion is so violent that it forces atoms together to create the heaviest elements in the universe: gold, silver, platinum, and uranium. We are star stuff. This brings us to the most profound connection between astronomy and biology. This is the concept that changes how we see ourselves. When the universe began, it was very simple. There were only two main elements, hydrogen and helium. There was no carbon to make cells or DNA, there was no oxygen to breathe, there was no calcium for bones, and no iron for blood. So where did the ingredients for your body come from? They were cooked. Every atom of carbon in every cell of your body was made inside a star that lived billions of years ago. Every atom of calcium in your teeth was forged in the red-hot core of a dying giant. Every atom of iron in your blood, which turns red when it binds with oxygen, was created in the violent heart of a supernova explosion. The gold in the jewelry you wear was created in the final split-second death of a massive star. When these stars exploded, they blasted these elements out into the cosmos. They became great clouds of dust, new nebulae, rich with the chemical ingredients for life. Billions of years ago, near where our solar system is now, one of these enriched clouds collapsed. It formed our sun, but the leftovers, the heavier dust rich in carbon, oxygen, silicon, and iron, clumped together to form the rocky planets. One of those planets was Earth, and from that stardust life emerged. We are not separate from the universe. We are the universe looking at itself. The boundaries between physics and biology dissolve. The iron in a wrench and the iron in your blood came from the same cosmic forge. We are, in a very literal sense, nuclear waste. but we are the most beautiful nuclear waste imaginable. We are the recycled remnants of ancient stars that sacrificed themselves so that we could exist. As the astronomer Carl Sagan famously said, the cosmos is within us, we are made of star stuff. This cycle of birth, fusion, death, and rebirth is the engine of creation. The violence of the supernova is necessary for the quiet miracle of a beating human heart. It is a continuous flow of matter, changing forms from a gas cloud to a burning star to a rocky planet, and finally to a conscious human being capable of wondering about it all. To understand the heart of our galaxy, we must first understand the body that holds it. Imagine looking down at the Milky Way from far above in deep space. It does not look like a random scattering of lights. Instead, it looks like a magnificent glowing pinwheel spinning slowly in the dark. This is our home, a barred spiral galaxy. It is a flat disk made of stars, gas and dust that spans over 100,000 light-years across. We live in the quiet suburbs of this galaxy, located on one of the outer spiral arms known as the Orion Arm. From our position, the galaxy looks like a milky band of white light, stretching across the night sky. But if we could travel inward, leaving our quiet neighbourhood behind, the scenery would change dramatically. We are moving away from the peaceful silence of the outer rim and heading toward the bustling, chaotic and dazzling downtown of our galactic city. As we travel closer to the centre, the structure becomes distinct. We see vast arms curving gracefully around a central core. These arms are factories of creation where pink clouds of gas give birth to new stars and blue clusters of young suns burn furiously. But our destination lies beyond these arms, deep inside the bright yellowish bulge that glows at the very centre. The journey into the bulge. As we leave the spiral arms and enter the region known as the galactic bulge, the environment changes completely. In our own neighbourhood, near the sun, stars are far apart. The nearest star to us is over 4 light-years away. It is like having a house where your nearest neighbour is across an entire ocean. It is lonely and dark. However, in the galactic bulge, the real estate is much more crowded. Here, stars are packed tightly together. If you lived on a planet in this region, you would never know true night. The sky would be blazing with the light of thousands of stars, some so close they would shine as brightly as the full moon. The night sky would be a ceiling of diamonds. The space here is also thick with dust. These are not empty voids, they are filled with massive clouds of gas and dust that block visible light. Astronomers call this the zone of avoidance because it hides the centre from our normal telescopes. To see through it, we must look with magic eyes, using infrared light and radio waves that can pass through the heavy dust curtains to reveal the secrets hiding behind them. As we push through these thick clouds, the radiation levels rise, the magnetic fields twist and snap. We are approaching a place of extreme energy, a place where the laws of nature are pushed to their absolute limit. The sleeping giant Sagittarius A star. At the precise geometric centre of the Milky Way lies an object of terrifying power and mystery. For a long time, astronomers knew something heavy was there because of the way the stars were moving, but they could not see it. It is a heavy, invisible ghost. We call this object Sagittarius A star. It is a supermassive black hole. When we say supermassive, it is almost impossible to comprehend the scale. Imagine the mass of our Sun, which is already huge. Now imagine 4 million suns crushed together. Now take all that mass 4 million times the weight of our Sun and squeeze it into a ball that would fit inside the orbit of the planet Mercury. Because it is so dense, its gravity is inescapable. It is a bottomless pit in the fabric of the universe. It is not a vacuum cleaner sucking things in randomly. Rather, it is like a patient spider sitting in a web. If you stay far enough away, you are safe. But if you cross a specific invisible line known as the event horizon, there is no turning back. Not even light, the fastest thing in the universe, can escape its grip. That is why it is black. It captures the light and never lets it go. The bending of space and time. Close to Sagittarius A star, reality begins to warp. This is where the physics of Albert Einstein becomes visible. The black hole is so heavy that it does not just pull on physical objects. It pulls on the fabric of space and time itself. Imagine placing a heavy bowling ball on a trampoline. The fabric curves down around the ball. Now imagine that curve is so deep it becomes a bottomless funnel. This is what the black hole does to space. But it also bends time. This is a concept called time dilation. The gravity is so intense that time actually flows slower the closer you get to the black hole. If you were brave enough to fly a spaceship close to the black hole without falling in and spent just a few hours there, you might return to Earth to find that years or even decades had passed. Near this immense gravity, time moves differently compared to the time in the quiet suburbs of the galaxy. It is a natural time machine that travels only into the future. Furthermore, the light from stars sitting behind the black hole does not travel in a straight line. The gravity is so strong that it bends the light rays around the black hole, acting like a giant cosmic lens. This creates a glowing halo of hot gas swirling around the darkness, heating up as it spins closer to the drain. The dangerous dance of the S-stars. You might think that the centre of the galaxy is a graveyard where stars go to die. However, it is actually a place of frantic activity. Surrounding the black hole is a group of brave stars known as the S-stars. These stars are caught in a dangerous dance. They orbit Sagittarius A star at incredible speeds to avoid falling in. One famous star known as S2 swings around the black hole at speeds reaching nearly 5,000 kilometers per second. That is roughly 15 million kilometers per hour. To compare, a fast commercial airplane flies at only about 900 kilometers per hour. S2 is moving at a speed that is hard for the human mind to grasp. These stars are the proof of the black hole's existence. By watching them over many years, astronomers saw them whipping around an invisible point in empty space. The only thing small enough to be invisible yet heavy enough to fling huge stars around like toys is a supermassive black hole, the invisible anchor. It is easy to see the black hole as a monster, a destroyer of worlds. But in a way, Sagittarius A star is also the heart that anchors us. While the black hole does not directly control the orbit of every star in the galaxy, we are too far away for it to pull us personally. It represents the centre of gravity around which our galaxy formed. It is the hub of the wheel. The gravity at the centre creates a balance. It is a violent, radioactive and dangerous place, yet it maintains a strict order. It holds the billions of stars in the bulge together. It creates the gravitational stability that allows the spiral arms to maintain their shape over billions of years. Looking at the heart of the Milky Way, we see a paradox. We see a dark abyss that swallows light, yet it is surrounded by the brightest stars in the galaxy. We see a force that can tear apart solar systems, yet it acts as the anchor for our galactic home. It is a place of terrifying beauty, a reminder that our universe is governed by forces far greater and more majestic than we can fully comprehend. As we lift our gaze beyond the familiar spiral arms of our own Milky Way, we encounter a profound truth. Our galaxy is not an isolated island drifting alone in the void. It is part of a bustling, dynamic neighbourhood, locked in a gravitational embrace with a massive partner. If you look up at the night sky in the northern hemisphere far beyond the stars that form the constellation of Andromeda, you can spot a faint, fuzzy smudge of light. To the naked eye, it looks like a quiet, unmoving cloud. But this is a deception of distance. That smudge is the Andromeda galaxy, a majestic city of nearly 1 trillion stars, and it is the most significant player in our cosmic future. To understand this relationship, we must first understand our address in the cosmos. We live in what astronomers call the local group. This is a cluster of more than 50 galaxies, a cosmic village bound together by the invisible, relentless pull of gravity. Most of these galaxies are small dwarf galaxies that act as satellites hovering around the larger structures. But dominating this group are two giants, our Milky Way, and the slightly larger Andromeda. Together, these two heavyweights hold the group together, their combined mass acting as the gravitational anchor for the entire neighbourhood. While the rest of the universe is expanding with galaxies flying apart from one another at incredible speeds, our local group is different. Here, gravity is strong enough to overcome the expansion of the universe. We are not drifting apart, we are falling together. The most dramatic aspect of this local dance is the movement of Andromeda itself. While most galaxies in the universe are rushing away from us, shifting their light toward the red end of the spectrum, Andromeda is doing the opposite. It is rushing toward us. Every second that ticks by, the gap between our two galaxies shrinks by about 110 kilometers. That is an unimaginable speed by human standards, yet the distance between us is so vast, about 2.5 million light years, that the gap closes with agonizing slowness to our eyes. This leads us to a future event that is both terrifying and beautiful, the inevitable merger. In approximately 4 to 5 billion years, Andromeda will no longer be a faint smudge. It will dominate the night sky, growing larger and brighter until it rivals the brilliance of the Milky Way itself. Computer models predict that the two galaxies will not simply smash into each other like two cars in a head-on collision. Instead, they will perform a graceful, chaotic dance. They will pass through one another, their shapes distorted by the immense pull of gravity. Long tails of stars and gas will be pulled out from both galaxies, creating arcs of light across the heavens. Shutterstock. You might wonder what will happen to the stars, including our own sun, during this chaotic merger. Surprisingly, the chances of two stars physically colliding are almost zero. The space between stars is so incredibly vast that the galaxies are mostly empty space. They will pass through each other like two ghosts. However, the gas clouds, huge nebulas of hydrogen, will crash together. This will trigger a furious burst of new life, igniting a firestorm of star formation that will light up the new galaxy. Eventually, after billions of years of gravitational wrestling, the two spiral shapes will disappear. The supermassive black holes at their centers will spiral inward and merge, and the two galaxies will settle down into a single massive elliptical galaxy, often playfully referred to as Milkomeda. This brings us to the concept of time and how we perceive movement. To understand the galactic dance, we must shift our perspective from geological time to cosmic time. We are used to thinking of geological time, the time it takes for a mountain range to rise, or a canyon to carve out, as slow. A mountain might take 10 million years to form. To a human, that is eternity. But in the context of the universe, 10 million years is barely a heartbeat. The collision with Andromeda unfolds over a timeline that makes the age of the Earth seem brief. When we look at the Grand Canyon, we see layers of rock that record the history of millions of years. When we look at Andromeda, we are looking at a process that takes billions of years. If you were to film the movement of these galaxies and speed it up, you would see a fluid, liquid-like motion. The galaxies would look like whirlpools of light, spinning, stretching, and flowing into one another. The static universe we see at night is an illusion created by our short lifespans. We are like mayflies living for a single day, convinced that the mountain beside us never changes, simply because we do not live long enough to see it erode. This realization expands our minds. It reminds us that there is no true stillness in the universe. From the spinning of an electron to the orbit of a planet to the grand collision of galaxies, everything is in motion. Gravity is the conductor of this orchestra, pulling matter across voids that are impossible to comprehend. The local group is not just a collection of objects, it is a process. It is a story that is still being written. The inevitable union of the Milky Way and Andromeda serves as a reminder of nature's cycles. Just as stars are born and die, galaxies too evolve, merge, and transform. Our solar system will likely survive this merger, flung out to a new orbit in the suburbs of the new Milkomeda galaxy. The night sky on Earth, if Earth still exists and has inhabitants, will look drastically different. The familiar band of the Milky Way will be gone, replaced by a bright core of billions of older stars. In the end, looking toward Andromeda is not just about studying a distant object, it is about understanding our future. It teaches us that we are part of a flowing, changing river of stars. We are not fixed in place. We are passengers on a great galactic vessel currently sailing across the dark ocean of the intergalactic void, destined for a rendezvous that was set in motion billions of years before the first human opened their eyes. The universe is not a painting on a wall, it is a movie, and we are watching just a single frame of the grandest scene of all. We have spent a long time exploring stars, nebulas, and even our own galaxy, the Milky Way. But to understand the true shape of the universe, we must pull back. We must zoom out so far that the Milky Way, a disk 100,000 light-years across, becomes nothing more than a tiny speck of light. When we look at the night sky with our eyes, the stars seem scattered randomly. When we look with small telescopes, we see galaxies scattered like pebbles on a beach. But when we use our most powerful instruments and supercomputers to map the position of millions of galaxies, a breathtaking pattern emerges. The universe is not random. It is structured. It has an architecture. As we drift away from our home galaxy, we first encounter the local group. This is a small village of galaxies that includes us, Andromeda, and about 50 smaller dwarf galaxies. But even this group is just a tiny piece of a much larger puzzle. Gravity, the invisible sculptor of the cosmos, has spent billions of years pulling these groups together. The supercluster's cities of giants. As we continue to zoom out, we see that galaxy groups clump together to form massive structures called superclusters. These are the largest known structures in the universe. They are the metropolises of the cosmos, containing thousands of galaxies bound together by gravity. For a long time, astronomers thought we belonged to the Virgo supercluster. However, recent maps have shown us something even more magnificent. The Virgo cluster is just an arm, a suburb of a titanic structure known as Laniakea. The name Laniakea comes from the Hawaiian language and translates to immeasurable heaven. It is a fitting name. This supercluster spans over 500 million light-years across. It contains the mass of 100,000 trillion suns. Think of Laniakea like a giant watershed or a valley on Earth. On a mountain, water flows down different paths into a central valley. In space, gravity acts like that slope. Everywhere in Laniakea, galaxies are flowing like rivers toward a central gravitational point called the Great Attractor. We, along with thousands of other galaxies, are slowly sliding toward this dense center. The architecture, filaments and walls. If we zoom out even further beyond Laniakea, we finally see the grand design, the cosmic web. The universe looks exactly like a three-dimensional spider web. It is a complex scaffolding made of light and shadow. This structure is built from two main components, the filaments and the voids. The filaments are the threads of the web. They are long, thin strands of dark matter and gas that stretch across the universe for hundreds of millions of light years. These filaments act like cosmic highways. Gas flows along these strands, feeding the galaxies that are caught in them. Most of the galaxies in the universe, including ours, are strung along these filaments like pearls on a necklace or dewdrops on a spider's silk. Where two or three massive filaments intersect, we find the huge superclusters like Laniakea. These filaments are the dense, busy parts of the universe. They are where the lights are turned on. They are where life, stars, and energy exist in their highest concentration. The voids, the great empty. Between these glowing filaments lie the voids. These are truly terrifying places. They are gigantic bubbles of emptiness, regions of space that contain almost nothing. While the filaments are crowded with galaxies, the voids are dark, cold, and lonely. A void can be hundreds of millions of light years across. If you were in the center of a large void, you might not see a single galaxy near you. The sky would be incredibly black. These voids take up the vast majority of the volume of the universe. Imagine a sponge. The material of the sponge represents the filaments where the galaxies live. The holes in the sponge represent the voids. The universe is mostly empty holes defined by thin walls of matter around them. One famous example is the Boötes void, often called the Great Nothing. It is a sphere of emptiness nearly 330 million light-years in diameter. If the Milky Way were in the center of the Boötes void, we would not have known other galaxies existed until the 1960s because they would be too far away to see with early telescopes. The neural network of nature. When scientists run computer simulations to recreate the growth of the universe from the Big Bang to today, the resulting image of the cosmic web is striking. It looks familiar, it looks biological. The cosmic web looks almost exactly like the neural network of a brain. If you put a picture of a mouse's brain cells under a microscope next to a computer model of the universe, it is very difficult to tell them apart. Both have dense nodes, nuclei in the brain, superclusters in space. Both have long, thin connections, axons in the brain, filaments in space. Both are separated by empty spaces. Does this mean the universe is a giant brain? Not necessarily. It is likely a case of physics following the most efficient path. Gravity shapes the universe and biological forces shape the brain, but they both follow similar mathematical rules of connectivity and growth. Nature tends to repeat its best designs, whether on the scale of a microscopic cell or a structure 10 billion light-years wide. Dark matter, the invisible skeleton. It is important to remember that what we see, the shining galaxies and glowing gas, is just the decoration. The cosmic web is actually made of dark matter. We cannot see dark matter, but we know it is there because of its gravity. Think of the cosmic web like a Christmas tree in a dark room. The galaxies are the colourful lights. We see the lights, but we know they must be hanging on something. They are hanging on the branches. In the universe, dark matter forms the invisible branches, the filaments. Regular matter, the atoms that make up stars and us, is just the light that clings to this dark skeleton. Without dark matter, there would be no web, no galaxies, and no us. Our place in the web. Understanding the cosmic web forces us to confront our size. We started this journey on Earth. Earth orbits the Sun. The Sun is one of hundreds of billions of stars in the Milky Way. The Milky Way is a relatively small galaxy in the local group. The local group is a tiny appendix on the edge of the Laniakea supercluster. Laniakea is just one bright knot in a single filament, and that filament is just one tiny thread in a web that stretches for 93 billion light-years. From this vantage point, our entire history, every human who has ever lived, every war, every invention and every dream has taken place on a subatomic particle within this colossal web. We are incredibly small, but there is a beauty in this perspective. We are the part of this massive, unthinking web that has woken up. We are the eyes of the universe. Through us, this massive network of gas and gravity has developed the ability to look at itself and marvel at its own structure. We are dust, yes, but we are dust that has figured out where it came from. To understand where we come from, we must first embrace a mind-bending truth about the nature of observation. Looking out into deep space is exactly the same thing as looking back into time. This happens because light, despite being the fastest traveller in the cosmos, does not move instantly. It travels at a specific finite speed. It takes time to get from point A to point B. Think about the moon. It takes light about 1 second to travel from the moon to Earth. Therefore, when you look up at the night sky, you're not seeing the moon as it is now. You are seeing it as it was 1 second ago. The sunlight you feel on your skin left the sun 8 minutes ago. If the sun were to suddenly vanish this very instant, we would not know about it. We would not see the darkness or feel the cold for 8 whole minutes. We live in the past of everything we observe. As we look deeper into the universe, we look further back into history. When we observe the nearest major galaxy, Andromeda, we are seeing light that has been travelling for 2.5 million years. We are seeing that galaxy as it existed when early ancestors of humans were just beginning to use stone tools. In this way, telescopes are not merely magnifying glasses, they are time machines. The deeper we gaze, the closer we get to the beginning of everything. Naturally, astronomers wanted to look back as far as possible, all the way to the Big Bang itself. However, for a long time they hit a wall. No matter how powerful the telescope, there was a limit to how far back we could see in. This was not a failure of technology. It was a limit imposed by the laws of nature. To understand this barrier, we have to imagine what the universe was like in its infancy. The wall of fog. Imagine the early universe not as the dark, empty void with scattered stars that we see today, but as a blindingly bright, incredibly hot soup. In the very beginning, mere moments after the Big Bang, the universe was so hot and dense that atoms could not hold together. Everything was a chaotic storm of particles. Protons, neutrons, and electrons were flying around at wild speeds, smashing into each other. In this environment, light was trapped. A particle of light known as a photon could not travel in a straight line. Every time it tried to move, it would almost instantly crash into a free-floating electron. Think of this like trying to drive a car through a dense, glowing fog. In a thick fog, the light from your headlights hits water droplets and scatters in every direction. You cannot see the road ahead, you only see a wall of white. In the early universe, the fog was made of electricity and plasma. Because the light was constantly bouncing around trapped inside this hot soup, the universe was opaque. It was not transparent. If you could somehow survive standing in that early universe, you would not be able to see your own hand in front of your face. You would be immersed in a blinding, uniform brightness with no shadows, no shapes, and no darkness. This state lasted for thousands of years. The universe was expanding and cooling, but it remained too hot for the fog to clear. The moment of clarity. The great turning point arrived approximately 380,000 years after the Big Bang. While this sounds like a long time to us on the scale of the universe, it is less than the blink of an eye. By this time, the universe had expanded enough that the temperature dropped significantly. It cooled down to about 3000 degrees Kelvin, roughly the temperature of the surface of a small red star. At this specific temperature, a critical change occurred. The heat energy became low enough that the frantic electrons finally slowed down. They were captured by protons to form the very first complete atoms of hydrogen and helium. Scientists call this event recombination. This was the moment that the cage was opened. When the electrons were locked into orbits around protons to create atoms, they stopped blocking the path of the light. The fog of free electrons suddenly vanished. The universe became transparent. For the first time in cosmic history, light could travel freely across space without hitting an obstacle. That initial trapped flash of light, the glow of the primal fire, was suddenly released. It raced outward in all directions, marking the moment the universe opened its eyes. The fossil of light. So what happened to that ancient light? It did not simply disappear. It is still travelling through the universe today, washing over us from every direction. However, it has changed. As the universe has expanded over the last 13.8 billion years, the space through which that light travels has stretched. Imagine drawing a wave on a rubber band and then stretching the rubber band. The wave gets longer and flatter. The same thing happened to the ancient light. It started as high-energy, scorching white light, but as the fabric of space stretched, that light was pulled into the infrared spectrum, and eventually it stretched so much that it became microwave radiation. Today we call this the cosmic microwave background. It was discovered almost by accident in the 20th century by two radio astronomers who were troubled by a persistent static, or hiss, in their antenna. No matter where they pointed their device, the noise remained the same. They eventually realized they were not detecting interference from Earth, but the fading afterglow of the Big Bang itself. This radiation is the oldest thing we can ever see. If your eyes could see microwaves, the night sky would not be dark. Instead, it would glow with a uniform brightness in every single direction. It is a wall of fire that has cooled down over billions of years. It acts as a baby picture of the universe, showing us exactly what matter looked like when the universe was just 380,000 years old. The era of silence. After that brilliant flash was released and the universe became transparent, a profound change occurred. The glowing plasma was gone, replaced by neutral gas. The background light faded into invisible infrared. Suddenly the universe went dark. There were no stars yet. There were no galaxies. There were no suns to give off light. There were only vast cooling clouds of hydrogen and helium gas floating in the void. Astronomers call this mysterious period the Cosmic Dark Ages. It was a time of deep, heavy silence. The universe was simple and smooth, but in the absolute darkness, gravity was quietly doing its work. It was pulling slightly denser clumps of gas together. Over hundreds of millions of years, these clumps grew heavier and heavier, pulling in more and more Horus. The pressure in the centers of these dark clouds began to rise. The temperature began to climb again. The universe held its breath, waiting for the next great transformation. The Dark Ages represent the gap between the primal origin and the modern era of structure. We cannot see into the Dark Ages with standard optical telescopes because there was simply no light to see. We can only look at the cosmic microwave background behind it and the first galaxies that formed after it. It stands as the final curtain, the limit of our vision, reminding us that before the first star could shine, the universe had to endure a long, cold winter of silence. This echo of the beginning tells us that our universe started in fire, passed through a great transition to clarity, and drifted through an age of darkness before the lights finally turned on. When we stand outside on a clear, moonless night, the sky seems full. We see thousands of stars, and if we use a telescope, we can see billions of galaxies, glowing nebulas, and vast clouds of dust. It is easy to believe that what we see is everything that exists. We assume that the universe is made of the same stuff that makes up our bodies, our Earth and our sun atoms, protons, neutrons, and electrons. However, modern science has revealed a truth that is both humbling and terrifying. Everything we can see, touch, and photograph, every star, every planet, every gas cloud, and every person makes up less than 5% of the universe. The remaining 95% is totally invisible to us. It is not made of the atoms we understand, it does not give off light, and it does not reflect light. We cannot see it, but we know it is there because of how it pushes and pulls on the things we can see. We call these two mysterious components dark matter and dark energy. They are the ghosts in the machine, the invisible ocean in which our tiny boat of reality floats. The mystery of the spinning galaxies. The discovery of the invisible universe began with a puzzle about gravity. In the mid-20th century, an astronomer named Vera Rubin was studying how spiral galaxies rotate. A galaxy is like a giant merry-go-round made of stars. According to the laws of physics that we use here on Earth, a spinning object experiences a force that tries to throw things outward. To keep the stars from flying away into deep space, the gravity of the galaxy must hold them in. In our solar system, the planets close to the Sun, like Mercury, move very fast. The planets far away, like Neptune, move very slowly. If Neptune moved as fast as Mercury, the Sun's gravity would not be strong enough to hold it and Neptune would fly away. Scientists expected galaxies to behave the same way. Stars near the bright, heavy center should move fast, and stars at the dark outer edges should move slowly. But when Vera Rubin measured the speeds, she found something impossible. The stars at the outer edges of the galaxies were moving just as fast as the stars in the center. They were moving so fast that the galaxy should have torn itself apart. There was not enough visible matter, not enough stars or gas to create the gravity needed to hold on to those fast-moving outer stars. Rubin realized that something else must be there. There had to be a huge amount of invisible mass providing extra gravity to glue the galaxy together. Scientists calculated that to hold these galaxies together, there must be 5 times more invisible stuff than visible stuff. They called this dark matter, the invisible scaffolding. Dark matter is not dark like a shadow or a black hole. A black hole blocks light. Dark matter does not. It is completely transparent. If you held a lump of dark matter in your hand, you would not see it. In fact, you could not even hold it. It is a ghost substance. It passes right through the Earth, through your house, and through your body every second of every day without touching a single atom. The only way it interacts with the universe is through gravity. It has weight. We now believe that dark matter is the scaffolding of the universe. Imagine a spider web. You might not see the thin silk of the web at night, but you can see the morning dewdrops hanging on it. The visible galaxies are like the dewdrops, bright and obvious, but they are only hanging there because of the invisible web of dark matter supporting them. Without this invisible glue, galaxies would never have formed, stars would not have clumped together, and we would not exist. The opposite force, dark energy. If dark matter is the glue holding the universe together, dark energy is the force trying to rip it apart. For decades, astronomers knew the universe began with the Big Bang and has been expanding ever since. However, everyone assumed that this expansion would eventually slow down. This assumption was based on gravity. Since gravity pulls things together, the collective gravity of all the stars and galaxies should act like a brake on the expansion of the universe. Think of it like throwing a ball straight up into the air. The initial throw acts like the Big Bang, sending the ball upward, but as the ball travels, the Earth's gravity pulls on it, slowing it down until it stops or falls back. In 1998, two teams of astronomers set out to measure how much the universe was slowing down. They looked at distant exploding stars to measure the speed of expansion. What they found shocked the entire scientific world. The ball was not slowing down, it was speeding up. The expansion of the universe is accelerating. Galaxies are rushing away from each other faster today than they were yesterday. Gravity is losing the battle. To explain this, scientists realized there must be a mysterious energy filling empty space that pushes things apart. They named it dark energy. Unlike dark matter, which clumps around galaxies, dark energy is smooth and exists everywhere. It seems to be a property of space itself. As the universe expands, it creates more space. More space means more dark energy. More dark energy pushes the universe to expand even faster. It is a runaway feedback loop. Today, dark energy makes up roughly 68% of the total universe. It is the dictator of our destiny, the humility of ignorance. The terms dark matter and dark energy are misleading. They sound like we know what they are. In reality, they are just labels for our ignorance. A more honest name for them might be the unknown known gravity and the unknown repulsion. This realization forces a deep humility upon science. For thousands of years, humans believed we were the center of the universe. First, we thought the sun orbited the Earth. Then we learned the Earth is just one planet. Then we learned the sun is just one normal star. Now we have to admit that the very atoms we are made of, protons and neutrons, are not even the main ingredient of the universe. We are a rare impurity in the cosmos. We are the foam on top of a deep, dark ocean. The universe is not made for us. It is mostly made of something completely alien to our experience. The fading sky. The presence of dark energy has a profound effect on the future of our sky. Because the universe is expanding faster and faster, distant galaxies are being pushed away from us at incredible speeds. Right now we live in a golden age of astronomy. We can look out and see billions of other galaxies. We can see the history of the Big Bang, but this view will not last forever. Billions of years from now, the space between galaxies will stretch so fast that light from other galaxies will never be able to reach us. They will disappear beyond the cosmic horizon. They will fade into the blackness. Eventually our own galaxy will merge with our neighbours, but looking outward from that merged home, we will see nothing but empty darkness. Future astronomers born 100 billion years from now might look up and see only their own stars. They might conclude that their galaxy is the only thing in existence floating in a static eternal void. They will have no evidence of the Big Bang, no evidence of the expansion, and no evidence of the billions of other galaxies that we can see today. Dark energy is slowly erasing the history of the universe. It reminds us how lucky we are to be alive right now at the exact moment when the universe is clear enough to be understood, but before the darkness becomes absolute. The invisible universe tells us that there is much more to reality than meets the eye. It challenges us to keep looking not just with our eyes, but with our minds into the dark. Imagine standing in a wide open field on a perfectly clear night. You look up. Above you, the dark canopy is dusted with thousands of twinkling points of light. We know now that these are not just decorations, they are suns, massive balls of burning gas, many of them burning far brighter and longer than our own. Thanks to modern telescopes, we also know that the visible stars are just a tiny fraction of reality. In our Milky Way galaxy alone, there are estimated to be between 100 billion and 400 billion stars. Beyond our galaxy, there are likely 2 trillion other galaxies in the observable universe. The numbers are so large they become hard to imagine. A common comparison is that there are more stars in the universe than there are grains of sand on every beach on Earth combined. Recent discoveries have taught us something else too. Planets are common. Most stars have planets orbiting them. Many of these planets sit in what scientists call the Goldilocks zone, a region that is not too hot and not too cold where liquid water could exist. When you look at the math, it seems obvious that we should not be alone. With so much real estate and so much time, billions of years, life should be everywhere. The universe should be teeming with civilizations, some perhaps millions of years older and more advanced than us. We should see their megastructures blocking the light of stars. We should hear their radio signals buzzing through the cosmos. We should have been visited by their robotic probes. But when we turn our radio telescopes to the sky and listen, we hear only one thing static: the great silence. This confusing situation is known as the Fermi paradox. It is named after the physicist Enrico Fermi, who during a casual lunch conversation about aliens famously asked, "Where is everybody?" It is a simple question, but it haunts our understanding of the universe. If the probability of life is so high, why is the evidence for it zero? To answer this, scientists and thinkers have proposed many theories. Some are hopeful, while others are terrifying. The Great Filter. One of the most compelling ideas is called the Great Filter. This theory suggests that there is some massive, difficult hurdle in the development of life that makes it nearly impossible for a civilization to reach the point of space travel. The question is the filter behind us or is it ahead of us? If the filter is behind us, that is good news. It might mean that the jump from dead matter to simple life is incredibly rare. So rare that it has only happened here. Or perhaps the jump from simple cells to complex animals is the hard part. If this is true, we are the lottery winners of the universe. We made it through the bottleneck where everyone else failed. However, if this filter is ahead of us, that is a frightening thought. It implies that advanced civilizations inevitably destroy themselves before they can spread to the stars. Perhaps once a society discovers nuclear power, artificial intelligence, or biotechnology, they lack the wisdom to control it. They might burn themselves out in wars or environmental collapse. In this scenario, the silence of the sky is the sound of a graveyard. It suggests that intelligent life is like a flash in the pan. It flares up quickly and dies out just as fast. The zoo hypothesis. Another possibility is less dangerous but more humbling. This is the idea that advanced aliens exist and they know we are here, but they are choosing not to contact us. Think of how humans treat a wildlife preserve. We watch the animals, we study them, but we try not to interfere with their natural development. To a civilization capable of traveling between stars, we might seem like primitive bacteria or simple animals. They might be enforcing a prime directive to let us evolve on our own, waiting to see if we mature enough to join the galactic club. We could be living in a cosmic zoo, unaware of the keepers watching from a distance. The dark forest. A darker version of this is the dark forest theory. This idea suggests that the universe is a dangerous place, like a dark forest at night, filled with hunters. In this forest, the only way to survive is to stay quiet. Any civilization that reveals its location by broadcasting radio signals or sending out probes is immediately targeted and eliminated by others who view them as a threat. In this view, the silence isn't because no one is there, it is because everyone else is smart enough to keep their mouths shut. We humans broadcasting our television and radio into space for 100 years might be the foolish child shouting in a forest full of wolves. The possibility of rare earth. Finally, there is the simplest and perhaps loneliest answer. We are truly the first. Maybe the conditions required for intelligent life are so specific, requiring a stable star, a planet with a large moon to stabilize its tilt, a magnetic field to block radiation, and the right mix of heavy elements that Earth is a miracle. It is possible that in all the vast darkness, we are the only ones who can look up and wonder. The weight of loneliness. Regardless of which theory is true, the outcome for us right now is the same. For all practical purposes, we are alone. This silence changes how we view ourselves. For a long time, humans believed we were the center of the universe. Then science humbled us. We learned we live on an average planet, orbiting an average star in an average galaxy. We felt small and insignificant. But the Fermi paradox brings a different kind of significance back to humanity. If the universe is indeed dead and silent, then we are the anomaly. We are the exception. Think about the atoms in your body. They were forged in the hearts of dying stars billions of years ago. For eons, those atoms floated as dust and gas, completely unaware of their own existence, but now arranged in the specific pattern that makes you those atoms can think. They can feel love, sadness, curiosity, and awe. Through us, the universe has developed the ability to know itself. Without life, the universe is just a play with no audience, a massive, beautiful, violent display of physics that no one is around to appreciate. This makes the flame of consciousness incredibly precious. If we are the only ones, then we carry the entire weight of meaning for the cosmos. Every piece of art we create, every scientific discovery we make, every act of kindness we show is unique in the history of time. Our responsibility. This realization brings a heavy responsibility. If the Great Filter is ahead of us, we must be wise enough to navigate it. If we destroy our ecosystems or unleash weapons we cannot control, we aren't just ending our own story. We might be extinguishing the only light in a billion light years. We might be removing the only eyes that can see the beauty of the stars. The silence of the sky is not a sign of emptiness. It is a mirror. It reflects us back to ourselves. It tells us that we have nowhere else to go. No one is coming to save us. There are no alien ships descending to fix our climate or solve our conflicts. We are the crew of Spaceship Earth. Drifting through a quiet, dark ocean, we must realize that the most important thing in the universe is not out there among the distant galaxies. It is right here. It is in the fragile biosphere that clings to the surface of our rock. It is in the connection between one human being and another. In the face of the great silence, our differences, our borders, our politics, our wars seem incredibly small. The silence demands that we grow up. It demands that we recognize how rare and lucky we are to be here awake in a universe that is mostly asleep. We are the custodians of life's possibility, and until we hear a voice from the stars, we are each other's only company. We have traveled a long way together. We started with the violent birth of the cosmos in the Big Bang, witnessed the swirling dance of galaxies and watched life crawl from the oceans to look up at the sky with wonder. But now we must turn the dial of our time machine forward. We are not going years into the future or even millions of years. We are journeying into deep time. This is an era so distant that the present day, the time of humans, dinosaurs, and even the Earth itself seems like a single flash of lightning in a billion-year storm. To understand the destiny of the universe, we must first accept a hard truth. Nothing lasts forever. Just as humans are born and eventually pass away, so too do stars, galaxies, and the universe itself. The era of fading light. Imagine you are standing on a planet trillions of years from now. When you look up at the night sky, it's not like the sky we see today. Today our sky is full of thousands of glittering jewels, a tapestry of light. But in this distant future, the sky is mostly black. The great era of star formation is over. The factories that build stars have run out of fuel. The massive, bright blue stars died out long ago. The yellow stars, like our own sun, have also swelled up and faded into white dwarfs, small hot cores of dead stars that slowly cool down over billions of years. The only active survivors are the red dwarfs. These are small, dim stars that burn their fuel very slowly. They are the tortoises of the cosmos, living for trillions of years, while the hares, the big stars, burn out quickly. But eventually even the red dwarfs will run out of hydrogen. One by one, the lights in the cosmic house are being turned off. The universe gets darker and darker. When the last star flickers and dies, the universe enters the degenerate era. It becomes a graveyard of stellar corpses, white dwarfs, neutron stars, and black holes. The universe will be a cold, dark place with galaxies that are merely ghosts of their former glory drifting apart in the expanding void. The Great Decay. In this dark future, the universe is continuing to expand. It is stretching out, pushing these dead stars further and further apart. But not only are the objects moving apart, but the matter itself is also breaking down. There is a theory in physics that suggests even protons, the building blocks of atoms that make up you, me, and the chair you sit on, do not last forever. Over an unimaginable length of time, protons may decay. If this happens, the dead stars and planets will simply dissolve. They will lose their structure and turn into a fine mist of subatomic particles and radiation. If you were a traveller in this era, you would see solid objects slowly vanishing into thin air, returning to the void. The concept of touch would disappear as there would be nothing solid left to hold. The era of black holes. After the stars and planets dissolve, the only things left are the monsters of gravity, the black holes. For a long time, a timescale so huge we can barely write it down. The universe will belong to them. They will sweep through the darkness, swallowing any stray particles they find. But even these giants are mortal. A brilliant physicist named Stephen Hawking taught us that black holes are not completely black. They emit a very faint glow now known as Hawking radiation. They leak energy. Slowly over eons they lose mass. A giant black hole might take a number of years equal to a 1 followed by 100 zeros to evaporate. This is a number so large that if you wrote a 0 on every atom in the universe, you still would not have enough space to write the full number. But eventually they too will shrink. In their final moments, they will explode in a blinding flash of light, the last fireworks the universe will ever see, and then they will be gone. The two paths, fire or ice. How exactly does it all end? Scientists propose two main possibilities depending on the power of dark energy, the mysterious force pushing the universe apart. 1. The Big Rip. If dark energy becomes stronger over time, the expansion of the universe will become violent. It will not just push galaxies away from each other, it will tear them apart. Then it will tear solar systems apart. Then it will rip planets away from their stars. In the final terrifying fraction of a second, the expansion will be so fast that it rips atoms apart. The fabric of space-time itself shreds. This is a violent, chaotic end where everything is torn asunder. 2. The Heat Death. The Big Freeze. This is considered the more likely outcome. In this scenario, the universe keeps expanding forever. As it gets bigger, it gets colder. The heat spreads out until it is evenly distributed or distributed across the vast emptiness. In physics, this is called maximum entropy. Think of it like a cup of hot coffee sitting in a cold room. Eventually, the coffee cools down and the room warms up slightly until they are both the exact same temperature. Once that happens, nothing changes anymore. No energy flows. In the heat. Death, the universe reaches a temperature of almost absolute zero. No work can be done, no life can exist, no thoughts can be thought. The universe becomes a vast, cold, silent ocean of nothingness. Time without watchers. This brings us to a profound philosophical question. If there is no one left to count the seconds, does time still exist? In this distant future which we call the Dark Era, there are no events. A photon, a particle of light, might travel through the emptiness for 1 trillion years without hitting anything. If nothing changes, does time pass? For us, time is marked by events, a heartbeat, a sunrise, a birthday. In the Dark Era, there are no heartbeats and no sunrises. Time stretches out into an infinite flat line. A second and 1 billion years become the same thing, because nothing happens in either of them. The universe falls into a timeless sleep. The distinction between past and future dissolves because the state of the universe remains exactly the same forever. A beautiful acceptance. This picture of the future, cold, dark and empty, might sound depressing. It might make us feel small and meaningless. If everything we build, every piece of art we create, and every memory we hold will eventually dissolve into nothing, what is the point? But there is another way to look at it, a more beautiful way. The fact that the universe will die gives meaning to the fact that it is alive now. Think of a beautiful flower. Part of its beauty comes from the fact that we know it will wilt. If the flower were made of plastic and lasted forever, it would not be as precious. The fleeting nature of the bloom makes it special. We are living in the Goldilocks era of the universe. We are here during the brief shining moment when stars are burning, planets are warm and life is possible. We are the universe's way of experiencing itself before the lights go out. The concept of entropy, the tendency of things to move from order to disorder, is not an enemy. It is simply the price of existence. You cannot have a fire without burning the wood. You cannot have life without spending energy. The universe is spending its energy to create this magnificent complex reality we live in today, the echo. In the very end, when the cosmos is cold and quiet, the fact that we existed will still be true. Even if no one is there to remember it, the interactions of our atoms, the energy of our love and the light of our cities rippled through the fabric of space-time. We were part of the great story. We should not fear the heat death. Instead, it should teach us to value the warmth we have right now. We are huddling together around a campfire in a dark forest. We know the fire will eventually go out. We know the cold morning will come, but that does not mean we should be sad. It means we should enjoy the warmth, tell our stories, and appreciate the light while it burns. The silence of the distant future is not a tragedy. It is a peaceful rest after a long, energetic, and chaotic life. The universe started with a bang full of noise and fury. It ends in a library-like silence, having told all the stories it had to tell. And in that vast, beautiful silence, everything is finally at peace. We have travelled very far tonight. We have drifted past the swirling storms of gas giants, we have danced on the rings of Saturn, and we have floated through the silent, terrifying beauty of black holes. We have touched the very edges of time and witnessed the birth of stars. But now the infinite journey must pause. The vast canvas of the cosmos begins to fold gently in on itself, not closing but resting. Imagine yourself pulling back. You are no longer floating in the void, you are drifting closer to home. See the great spiral of our galaxy, the Milky Way spinning slowly like a wheel of light in the darkness. It is vast, but to you right now, it looks like a warm glowing island in the sea of night. You are drifting into one of its quiet arms. You pass millions of stars, each one a sun to its own worlds, but you do not stop. You are drawn to one specific gentle yellow star. As you get closer, you see the familiar blue marble suspended in a sunbeam. Earth. It is quiet. It is peaceful. It is the only home we have ever known. Descent slowly through the clouds. Feel the atmosphere wrapping around you like a blanket. Down past the mountains, past the sleeping oceans, past the forests that breathe in the night air. You are drifting right back into your room, right back into your body. Feel the weight of your body now. Feel the mattress beneath you supporting you. Feel the gravity of Earth holding you in a gentle embrace. Gravity is not just a force that pulls things down, it is the Earth's way of hugging you, keeping you safe, ensuring you do not float away. You are grounded. You're here. You are safe. Take a deep breath. Inhale slowly, filling your lungs with the air of this planet. Exhale slowly, letting go of the vacuum of space. As you lie here in those quiet moments before sleep takes you, you might ask, why do we do this? Why do we look up? Why do we build telescopes to see light that left its source billions of years ago? Why does the human mind yearn to understand things so much bigger than itself? The answer is simple, and it is beautiful. We study the universe because we are the universe. Think about the atoms in your body, the iron in your blood, the calcium in your bones, the carbon in your skin. Every single one of those tiny particles was cooked inside the fiery hearts of ancient stars. Long ago, those stars exploded, scattering their dust across the cosmos. That dust gathered together over eons to form the sun, the earth, and eventually you. You are not a Zironitor in this universe. You are not an outsider looking in. You are a child of the cosmos. You are stardust that has come together for a brief and magical moment to come alive. You are the universe having a dream. You are the universe waking up to look at itself. When you look at the stars, it is just the universe looking back at its own reflection. This is why we search. We are trying to remember where we came from. We are trying to understand our own story. And what a story it is. It is a story of chaos turning into order. It is a story of light emerging from darkness. It is a story that has led to this very moment where you lie in bed, breathing, thinking, feeling. But for now, the searching is over. The questions do not need answers tonight. The mysteries of dark matter and the expansion of space can wait. They will still be there tomorrow. They will still be there in 1,000 years. The universe is patient. It has plenty of time, and so do you. Now is the time to let the mind rest. You have used your imagination to travel light years, and now your imagination deserves to sleep. Let go of the need to understand. Let go of the need to know why. Just be, just exist. Feel a wave of relaxation traveling from the top of your head down to your toes. Let your forehead smooth out. Let your eyes relax in their sockets. Let your jaw loosen. Let your shoulders drop, sinking deeper into the bed. Imagine that the darkness behind your closed eyes is the same comforting darkness of deep space. It is not empty. It is full of potential. It is a velvet cloak wrapped around you to keep you warm. In this darkness, there is no noise, there is no rushing. There is only the slow, steady rhythm of your own heart. Thump, 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 thump. It beats in time with the rhythm of the world. Everything in the universe works in cycles. Stars are born and stars die. Galaxies spin, planets orbit. The moon waxes and wanes. The tide comes in and the tide goes out. And you too are part of this cycle. You have had your day of activity, of thinking, of doing. Now is your time for the cycle of rest. Trust in that cycle. Trust that the sun will rise again tomorrow just as it has for 4.5 billion years. You do not need to worry about the morning. The universe has the timing under control. Your only job right now is to let go. Drift deeper now. The images of the cosmos are fading into a soft grey mist. The numbers, the distances, the theories, they are all dissolving like sugar in warm water. They are gone. There is only you. There is only this moment. There is only peace. You are small, but you are significant. You are a conscious spark in a vast, dark room, and that makes you precious. But even a spark needs to rest to burn bright again. So sink into the mattress. Let your limbs feel heavy as lead, as heavy as the center of a planet. You are sinking down, down, down into a soft, warm cloud of sleep. The universe loves you, it created you, it sustains you, and now it sings you a silent lullaby. The stars are keeping watch overhead. The earth is holding you steady below. The air is flowing rhythmically within. Everything is right. Everything is in its place. There is nothing left to do. There is nowhere left to go. You are home. Sleep now. Drift into the quiet. Drift into the deep. Good night to the stars. Good night to the moon. Good night to the earth. Good night, traveller. Sleep.